called alkaline. Sodium oxide and potassium oxide dissolve in water and form sodium hydroxide and potassium hydroxide respectively. Metals differ in their reactivity towards oxygen. Metals like sodium, potassium are highly reactive. They catch fire very easily when they are exposed in air. Hence, to protect them from accidental fire, they are immersed in kerosene oil. At ordinary temperature, the surfaces of some metals like magnesium, aluminum, zinc, and lead are covered with a thin layer of oxide. This oxide layer prevents the further oxidation of metal. Iron does not burn on heating. Copper also does not burn on heating. Gold and silver do not react with oxygen even at high temperature. The process of formation of a thick oxide layer of aluminum is called anodizing. When exposed to air, aluminum develops a thin oxide layer. Anodizing is done to improve the resistance of aluminum to corrosion. During anodizing, a clean aluminum article is taken as an anode. This is electrolyzed by using dilute sulfuric acid. During the process of electrolysis, the oxygen gas released at the anode makes the thick protective oxide layer. This oxide layer can be dyed easily, which gives aluminum articles an attractive tarnish. Nonmetals react with oxygen to form oxides which are either acidic or neutral in nature. For example, sulfur reacts with oxygen to form sulfur dioxide, which is acidic in nature. Nitrogen reacts with limited supply of oxygen to form nitric oxide, which is neutral oxide in nature. Nonmetal oxides dissolve in water to form acidic solutions. For example, sulfur dioxide dissolves in water to form sulfurous acid. While moving down in the activity series, the reactivity towards water decreases. Potassium and sodium and calcium can react vigorously even with cold water with the liberation of hydrogen gas. Magnesium reacts very slowly with cold water but can react vigorously with hot water to produce hydrogen gas. Metals like aluminum, zinc, and iron does not react with cold water or warm water but can react with hot steam. Nonmetals do not react with water. The metals which are present above the hydrogen in the reactivity series can reduce hydrogen ions from the acids like hydrochloric acid and sulfuric acid. Reactivity decreases on moving down the group in the series. Potassium, sodium, they react vigorously with dilute acid to liberate hydrogen gas. Calcium, magnesium also reacts vigorously but slowly with acids, liberating hydrogen gas. Copper does not react with dilute hydrochloric acid, even on heating, but it reacts with dilute sulfuric acid on heating. Generally, nonmetals do not react with acids. Only a few metals can react with strong bases to form metal salts and release hydrogen gas. For example, aluminum, zinc, and lead. Zinc metal reacts with sodium hydroxide to form sodium zincate and hydrogen gas. The reaction of nonmetals with bases are complex. The arrangement of metals with decreasing order of their reactivity is known as the activity series. In the activity series, highly reactive metals placed at the top and least reactive metals are placed at the bottom. Gold, placed at the bottom of the series, is the least reactive among the metals, and potassium, placed at the top, is the highly reactive metal. Hydrogen is the non-metal which is included in order to compare the reactivity of metals. The metal placed higher in the series can displace the other metal from its salt solution. Thus, potassium can displace all other metals from their salt solutions. For example, potassium can displace hydrogen from the acids. Metals of low reactivity cannot displace highly reactive metals from their salts. For this reason, oxides of highly reactive metals like magnesium and aluminum are not reduced easily either by hydrogen, carbon, or carbon monoxide. Metals that are placed below copper do not rust easily because of their low reactivity. The arrangement of metals in the decreasing order of their reactivity is known as the activity series. In the activity series, the most reactive are placed at the top, the least at the bottom. For any two metals in the series, the metal placed higher in the series can displace the other metal from its salt solution. For example, when iron metal is placed in copper sulfate solution, then copper from copper sulfate will be replaced by iron.